Hello and welcome. In this video, we are going to solve our question number 15 of Leetcode, that is three-sum problem. Okay, so in this video, we have given an integer array nums and we have to return all the triplets such that nums I, nums j, nums k, such that I is not equal to j, I is not equal to k, and j is not equal to k, and nums I plus nums j plus nums k equal to 0. So what does that means? Okay, so we have to find all the triplet for which if we are adding all the number, the sum is going to be equal to 0 and all the numbers should be unique. So if we are using this minus 1, then we are not using the same minus 1 for the second time. So for second time we will be using another minus 1 we can use. So this is okay, but we can't use the same minus 1 for two times. Okay, so all the indexes should be unique. That is what the here is mentioning, here is mentioned. Okay, I know should not be equal to j, and j I should not be equal to k, and j should not be equal to k. Okay, so how we can solve this problem? We have already solved a two sum problem. I would strongly recommend you to watch that video before starting to solve this problem. So if you not solve that problem, then please go and watch this video. Okay, so how we can solve this problem? So we can do it by using brute force method. So what will be brute force method? So we will be doing a for loop for I equal to 0 to n minus 2, and then inside this for loop we will be running another for loop j equal to I plus 1 to n minus 1, and inside this for loop we will be running another for loop, that is k equal to j plus 1 to n. Okay, and then we will be checking if array I plus nums I plus nums j plus nums k equals to target, then we will be storing triplet. Okay, so you can see this in this method we will be doing 3 for loop inside one. So this is going to be big O of n cube time complexity, as we are running in worst case we are running our for loop for n times. So time complexity is going to be big O of n cube and the space complexity is going to be big O of 1. So this is very much time consuming, so I would not advise you to go with this. So let's go some let's go for some optimized approach. So how we can optimize this approach? We can optimize this approach by using a sorted array. So first we have to sort our array. After sorting we will be able to apply after once we will be sorted this array, this is going to be something like minus 4, then minus 1 minus 1 0, okay, 1 2. So after sorting we know that we can easily find our target. So we will be taking one integer minus 4 and we will be finding the target remaining values in the remaining array. So minus 4 is the value that we have already taken, so our target will be going equal to 0 minus minus 4, that is 4. So in remaining array we will be finding 4. So for that we will be using two pointer method. Okay, that will be something like what we do in binary search. So I am going to explain this in codes, don't worry about that. So what will be pseudocode for that? So we'll be writing pseudocode for this. First we'll be running for loop I equal to 0 to n minus 2, and then we will be declaring a left equal to I plus 1 and right going to be equal to n minus 1. Okay, and we have to update our target also. Target is going to be equal to 0 minus nums I, and inside this we will be doing do two pointer and a store triplets if found. Okay, so you can see that first way to sort our array, which is going to be time complexity of big O of n log n, and inside this we will be running a for loop which is going to be n big O of n into, and again we will be doing this two pointer which is going to be big O of n, so big O of n square. So big of n square plus big of n log n time complexity it is going to take. Okay, so let's go to compiler and write this code for sim. So first we have to declare our result variable. So and then we have to sort our array. That is the basic requirement for our solution. Now run the for loop from I equal to 0 to num dot length minus 2 and I plus plus. Okay, now our first we have to check whether I is equal to 0 or I is great. If I is greater than 0, then nums I should not be equal to nums I minus 1, just to avoid the duplicacy that we have already seen here. Okay, so after that we will be doing two pointer inside this. So we will be declaring our left and right boundary for that. So left is going to be equal to I plus 1 and right is going to be equal to nums dot length minus 1 and our target is going to be equal to 0 minus nums I. Okay, now to the two pointer. So code for two pointer is going to be similar that we write in our binary search, but it is not binary search, it is two pointer, as we are not dividing our search space by two times, or no, yeah, we are not dividing our search space into by two times. So we are, this is not the binary search, this is two pointer. Okay, so we'll be doing this till left is lesser than right. Okay, now there will be a condition if nums of left plus nums of right equals to target, then we'll be doing some calculation inside this and storing the value. And else if nums of left plus nums of right is lesser than target, in this case we will be moving our left to one side. Okay, and in else case moving our right to one minus. Okay, now add all that, or add the triplet inside our result. So we'll be doing this using array dot age list method, and our triplets are nums I, nums of left, nums of right. Okay, and then we have to move our left and right pointer, left plus plus and right minus minus. And after that we have to make sure that we are not doing same calculation for the duplicate elements. So for that we have to iterate our left group while left is lesser than right, and nums of left is equal to nums of left plus 1. In this case we will be moving our left pointer to 1 forward. Okay, same for right pointer. This is just for avoiding the duplicacy. Okay, so nums left, sorry, we are writing for right. Okay, so nums right and nums right minus minus, in this case do right minus minus. Okay, so we are done with our code, just return the result. Now run this. Yeah, so first test case has been passed. Run the remaining test case. Now submit this. So our solution has been accepted and it is faster than 97%. So this is the one of the optimized approach. There can be many other approach also. So in case you learned something from this video, make sure to like the video, subscribe to the channel, and if possible please share this video among your friends. Thank you.